Okay, today we're gonna talk about DI method. Is basically integration by part. So, like when you have like a two function multiply together, function x and ln x, that kind of stuff. G times f, so it's u di. Because you cannot integrate this thing, but you can integrate this. Now, what does D stand for? D is stand for differentiation, and I is integration. Differentiation, you can integrate anything, but integration, you cannot. Sometimes you cannot integrate, like e to the x squared, e to the minus x squared, the famous Gaussian integral, the negative infinity to positive infinity. Okay, so when you write this, you want a plus, minus, plus, minus, plus, minus, like this. You're going forever, but don't do that. So we gotta start off with a plus first. Okay, let's look from something we cannot integrate. Well, we cannot integrate this. Let's integrate this. Sure. So let's integrate x. And ln x, we differentiate it. Because if you integrate ln x, you gotta use a di again. This you just get 1 over x. Pretty simple. And this, you get 1/2 x squared. Now, we keep integrating until we reach 0, but we never reach 0, so let's stop here. So we're gonna multiply by this, and the last row right here, so like diagonal like this, last row you're gonna multiply like this, Okay. This, and this cancel, so you get 1/2 x. So the first part, we get 1/2 x squared, so it's right, 1/2 x squared times ln x. That's the first part, minus the second part, which is 1/2 x. I don't know why that took me so long. And you want to integrate the last row. So like this. It's pretty easy to integrate. It's basically saying x over 2. X over 2. Okay? Integrate x over 2. That's easy. Just plus 1 and divide by 2. Divide by 2 just means multiply by 1/2. So we just get x over 4 to the second power like this, and ln x minus this x squared over 4 like this, plus c. There's your answer. Sorry for not writing x, I forgot. Okay, next one. X times cosine x. Well, we can integrate this and this. It don't really matter. But if you integrate this, you get x squared, 1/2 x squared. So like, get rid of it. Let's integrate cosine x. Sure. So put down plus minus like this. Just to make sure. You need 3. Don't need that much, but if you need 2, yes. Cosine. If you integrate this, you get sine x. If you integrate this again, you get minus cosine x. You integrate this, you get minus sine x. Let's do it one more time. If you integrate this, you will get positive cosine x. Okay, let's stop here. That's a lot. We don't need that much, but let's differentiate this. Differentiate this, you get 1. Differentiate this, you get 0. When you get 0, you stop. So we need the last 2 rows right here. Okay, so multiply by row like this. You don't gotta integrate the last one because you already know it's just 0, right? Wait a minute. Okay, I'm so sorry, but I forgot to turn the mic off. Hopefully you guys can hear me now. Sorry. So first part is x to the sine. x sine x times sine x. Negative, negative, positive. So like this. Don't forget the plus c. And we are done. That's it. It's pretty simple. It's not that hard. X squared e to the x. So let's use di to integrate this. Plus or minus, just to get ready. Let's put down 4. Let's just put down 4. Okay. Both of this you can integrate it, but let's differentiate this because you know it will reach 0. And let's differentiate this. Differentiate this how many times you want. It's still this. Yes. Keep going further. Yes. Let's put down 4 first. X squared. This differentiate this, you get 2x. Differentiate this, you get 2. Differentiate this, you get 0. Before I erase this, multiply by the row like this. And you don't need the last one because you already know this is 0. But I'm just going to do it anyway. So first answer, x squared, 2 to the x, subtract 2x times e to the x. Then plus 2e to the x like this. And plus the c as well. Wait. And yeah, that's it. Pretty much, that's it. Let's give it integral. Tangent. Tangent, basically what? Sine of a cosine. And yes, we can use the DI method for this. Plus or minus. Plus minus like this. 1 over cosine x. Nah, that doesn't look pretty great. We don't really need to use the DI method for this. Let's give it another integral. I'm thinking, hold up. I got it. I got an integral in mind. Let's try x squared. Not x cubed. We already used x squared. X cubed sine 2x. Negative x. Sure. Let's use the DI method. Plus or minus. Let's start bigger because farther. So we can just use some space. Let's set it up. Let's differentiate x cubed, as you know, because it's gonna reach 6x. So since it's 0, you don't really got to write it. But you need to, because it's gonna be 1 part right here and you're gonna multiply like this. You can use the user for this, but the fastest way to do it is basically just divide by what's inside here. So you just get, well, let me do this integral for you so you guys can see. You can use a u sub, it's pretty easy. So du equal negative dx. So dx equal negative du. So you get a negative number right here of sine u du. This is negative cosine, but the subtraction make it positive. So cosine x. Okay? And integrate this is pretty easy. So integrating this. So my mic ran out of battery. I might charge it later. Hopefully you guys can still hear my voice. Integrate this. This is pretty easy. This is basically sin x. And this is negative cosine x. And this is basically negative sin x. Yes, it's a lot of work, but okay, here's the answer. I might just got it right here. So first answer, minus 3x squared times sin x. Then positive negative equal negative. So negative 6x cosine x. Then positive, negative, negative, positive. So plus 6 sin x. Then the plus c. That's it for the DI method.